Hello everyone and welcome back. Now today we are going to learn what is Cayley Hamilton theorem and some applications of Cayley Hamilton theorem. Now what the statement says, every square matrix satisfies its own characteristics equation. तो जो मैट्रिक्स है उसे स्क्वायर मैट्रिक्स होना है, either 2x2, 3x3 or 4x4, then satisfies its own characteristics equation. Okay, so I hope you still remember what is characteristics equation. Suppose capital A is a matrix, square matrix, okay, of any order. Then इसका जो characteristics polynomial होगा वो क्या होगा? Characteristics polynomial, that will be what? A minus lambda I. Now when we expand this determinant, no, A minus lambda I, we get a polynomial. If the matrix is 2x2, then we will get a polynomial of degree 2. If the matrix is of order 3, then we will get a polynomial of degree what? 3. Like this, it will continue. Suppose here the matrix is of order n. Order n. So it will be like this, minus 1 to the power n, then lambda to the power n, plus a1 into lambda to the power n minus 1, a2 into lambda to the power n minus 2. So like this, the last term is suppose an. Now why I am writing minus 1 to the power n here? See, if you check the problems of characteristics roots, then if the matrix is 2x2, it is plus lambda square. Plus will come. First term will be lambda square. But whenever we take a 3x3 matrix, this term will be minus lambda cube. Again, if the matrix is 4, then it is plus lambda to the power 4. So it is continuously changing depending on the value of n. If n is even, the first term is positive. If n is odd, then the first term is what? Negative. Okay. So that's why we don't know what is the value of n, is even or odd. So that's why we have to put minus 1 to the power n. Now what the theorem states, that satisfies its own characteristic equation. So by Cayley Hamilton theorem, this determinant a minus lambda I should be equals to what? 0. So what is this equation? Capital A is a matrix and this is its own characteristics equation. So this will satisfy. So what we get here? Minus 1 to the power n, then suppose lambda to the power n, here a1, a2, these are all constant, n minus 1, lambda to the power n minus 2, so like this, equals to 0. Now after setting to 0, now we can cancel this term, minus 1 to the power n. So finally we have lambda to the power n, a1 lambda to the power n minus 1, then an equals to 0. So this is the characteristics equation. So according to statement, this characteristics equation must be satisfied by capital A. That is, so here you can better write characteristics equation of capital A. Okay. So now this will be by Cayley Hamilton theorem. Now this is the characteristics equation. Now this will be satisfied by capital A according to Cayley Hamilton theorem. We'll do some examples where we'll check. So it will be a to the power n, a1 a to the power n minus 1, then a to the power n minus 2. So like this, the last term will be an, and with this we have to write identity matrix because this is a scalar quantity and this is a matrix equation. So we have to write I equals to null matrix. So whatever characteristics equation you will get, that will be satisfied by capital A. So this is the theorem. Okay. Now let's do one problem so that the idea will be more clear to all of us. So we have taken a matrix which is of 2x2, so means it is a square matrix. Satisfy Cayley Hamilton theorem. First we have to verify that this particular matrix satisfy or verify Cayley Hamilton theorem. So for that, what we need to find? Characteristics equation. Okay, so the characteristics equation is given by a minus the determinant a minus lambda equals to 0. So lambda is unknown, So here A is 1, 4, 2, 3. Then lambda into our I is 1, 0, 0, 1. Identity matrix equals to 0. So this will be our 1 minus lambda, 4, 2, then 3 minus lambda equals to 0. So after that we have to expand this particular determinant. 1 minus lambda, 3 minus lambda, and then it's 8 equals to how much? 0. So if we expand it, we will get lambda square, and then minus lambda minus 3 lambda. So it is minus 4 lambda, and then 3 minus, it is minus 5 equals to what? 0. Now if we factorize it, you will get lambda minus 5, lambda plus 1 equals to 0. So this implies you get two values of lambda, 5 and then what? Minus 1. So these are what? Characteristics roots. Okay. So we already get this in the PDF, sorry, in the lecture where we see how to find characteristics roots and characteristics vector. So if you didn't watch that one, so you kindly go and watch how to find characteristics roots and characteristics matrix. So there you will get this idea. So now we are not concerned about these characteristics roots here. Okay, these things we don't need. So this line is important for us. So this is the characteristics equation. So by Cayley Hamilton theorem, this particular equation, no, I'm talking about this equation. This particular equation is what? Satisfies by the matrix capital A. That we have to check satisfies or not. Okay. So whenever you are asked to verify, so no need to find the characteristics roots. So it's just for your convenience, I find it so that you can remember what we actually did in characteristics matrix and characteristics equation. Okay. After that, now we have to check that this particular characteristics equation will be satisfied by the matrix capital A. Now, first we have to find A square. The first time is lambda square, right? So in place of lambda square, we have to find A square. So A square will be the same thing. We have to multiply twice. 2, 3, again 1, 4, 2, 3. So after multiplication, you will get a matrix. It's 1 into 1, 4 into 2. So it's 9. Then 16, it will be 8, and then 17. So let us, so therefore now we are taking this particular equation but with A, capital A. Lambda will be replaced by A. So it's A square 4A minus 5I. Okay, because other two are matrix, we cannot write a scalar, so that have to be 5I. Now A square is our 9, 16, 8 and then 17 minus 4A. So we have to multiply this matrix A with 4. So it will become 4, 16, 8 and then what? 12. And then finally minus 5I. So 5 into I is 1001. So after multiplying with 5, 5005. Now let us see what will come. Now see 9 minus 4 minus 5. So it is 0. 16 minus 16, 0. So all will become 0. So what does it mean? It means that the matrix capital A satisfies its own characteristics equation. So hence Cayley Hamilton theorem is what? Verified. So this is one type of problem. Okay. Just you have to find the, so you can take one 3 by 3 matrix also. After taking 3 by 3 matrix, you find this equation characteristic, that there you will get lambda cube, and then accordingly you have to find A cube, A square, put in the left hand side, replace lambda by A. So if it is 0, that means what? Cayley Hamilton theorem is verified. There is one more part. Okay, express this particular expression, that is a to the power 5 minus 4a to the power, this big expression. Now we have to express this in terms of A. Let us see what will come. Okay. Now for this particular equation, we have already proved this: a square minus 4a minus 5i equals to 0. So let it be equation number 1. So we have already this one. Now what is the expression? A to the power 5 minus 4a to the power 4, 7a cube plus 11a square minus a minus what? 10i. Okay, so it's a very big expression, but we'll use this relation. Okay, this relation we can use now. So how we'll do the calculation? You see, I'm writing equation 1 thrice. Suppose a square minus 4a minus 5i. So leaving some space, again a square minus 4a minus 5i. Now see, what is the first term? Our first term is a to the power 5. Okay, first term is a to the power 5. So we need one more term, I guess. A to the power, let's see. So the first term is a to the power 5, but here the first term is what? A square. So to get a to the power 5, we have to multiply it by a cube. So now you see, this into this is a to the power 5. Now you multiply these two terms. After multiplying these two terms, what will get? If we multiply these two terms, it is what? Minus 4a cube. So exactly this term is automatically coming. Then multiply this term with this. So if we multiply these two terms, it is minus how much? Minus 5a cube I. 5a cube I. So 5a cube into I is again a cube. So you have minus 5a cube. But what we need? We need 7. We are getting 5 minus 5, but we need 7. So here we have to multiply by twice a. Okay. So from this you are getting minus 5a cube, and from this you are getting minus 2a cube. So ultimately this term will also balance. Now multiply this with this. So if we multiply these two, what will get? We are getting how much? 6a square. Okay, so we need one more term. So a square minus 4a minus 5i. Okay, so see, if we multiply these two, how much you are getting? We are getting 6a square, but here we have 11a square. So let us give one 5 here. So 6a square plus 5a square. So this term is also coming. Again you multiply this term with this term. So how much it is? It is 10a. Okay, it is 10a. And here if you multiply this with this, you are getting minus how much? Minus 20a. Is it all right? Yeah. So if you multiply these two, this with this, we are getting how much? We are getting 10a plus 10a. And if we multiply these two, then we are getting minus 10a. So what is missing here? So plus 10a and minus 20a. So we have to give minus 20. Na? So we need minus 1. So we have to give plus 9a. So see, minus twice a into minus 5a is how much? 10a. Then if you multiply these two, you are getting minus 20a. So how much you will get? You will get minus 10a. But according to question, we need minus a. So for this thing, we have to add plus 9a. Okay. So is it all right? So let us see this term is coming or not. So here there is, I think I have made one small mistake. This into this is how much? 8a. Okay, 8a. So this will be a how much? 11a. So if it is 8a, so we need only 3. So this will be 3. Okay, this will be 3. So then this term will be changed. Okay, now let me check is all right or not. Plus 8a plus 3a 11a square. Okay, now it's all right. Then if we multiply these two, we'll get 10a. And if we multiply these two, how much you will get? minus 12a. So this is 2. So how much we have to put here? Plus a, because then only we will get minus a. So this is our only a. This term is done. Now multiply this with this. So how much it is? Minus 15i. Okay, minus 15i. But we have what? Minus 10i. So how much is extra? 5i is extra. Now see, interestingly, see from equation 1, no? Equation 1 is what? A square minus 4a minus 5i equals to 0. So this term, this particular term will become 0. This is 0. This is also 0. So first term will automatically vanish by using equation number 1. So what we are left out with? We have only two term. This is not a, I. So we have two term only. A plus how much? 5i. Okay. A plus 5i. So what is our A? A is 1, 4. Then 2, 3. And 5i. 5i is 5, 0, 0, 5. Okay. So this much is the answer. This is the answer. But if you need the matrix, then you can write like this. How much it is? 6, 4, 2, and then what? 8. Okay. So what to do? We have to express this equation. See, we have to express this particular expression as a linear polynomial A. So this one is the required linear polynomial. Okay, required polynomial. So this is not needed. Just I show that what is the matrix that we are getting. Okay. So here what we did, we take a matrix and first we verify that Cayley Hamilton theorem is verified, and then we express this particular expression in terms of A. Let us take one more different type of problem. Now see, here one 3 by 3 matrix is given, and here it is not asked to verify Cayley Hamilton theorem. We can use Cayley Hamilton theorem, and after using Cayley Hamilton theorem, we find A inverse. So we have so many different methods of finding A inverse, right? By adjoint, and then by some other methods, we can find the inverse, like row transformation. But here we have to find the inverse of the matrix by using what? Cayley Hamilton theorem. Okay, so let's do it. First, what to do? We have to find the characteristics equation. So characteristics equation is what? Determinant A minus lambda equals to 0. So this implies determinant, our A is 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. Okay, then lambda into our I will be 1 0 0 0 1 0 and then 0 0 1. This is 0. So this 2 minus lambda minus 1 1 minus 1 again 2 minus lambda minus 1 1 minus 1 again 2 minus lambda. Now you expand this determinant. Okay, so after expanding the determinant, you will get lambda cube minus 6 lambda square plus 9 lambda minus 4 equals to 0. Just expand this 3 by 3 determinant, this particular expression you will get. Now by Cayley Hamilton theorem, what you can say, this particular characteristics equation will be satisfied by capital A. Cayley Hamilton theorem, we have what you can write, a cube minus 6a square plus 9a minus 4i equals to 0. So here no need to show or verify Cayley Hamilton theorem, since we can use Cayley Hamilton theorem. So what is Cayley Hamilton theorem? This is the characteristic equation. So characteristic equation will be satisfied by its own matrix, that is what? Capital A. Now we have to find the inverse. So how will find the inverse? Pre-multiplying both sides by A inverse. So it will be a cube minus 6a square plus 9a minus 4i equals to null matrix. So when you multiply it, after multiplying this, you will get what? A square, you will get 6a, and here A inverse into A is I, and then last one is A inverse into I is only A inverse. Okay, so a square minus 6a plus 9i equals to 4a inverse. So what we need to find? We need a inverse. It will be 1 by 4 a square minus 6a plus 9i. Okay. So now we need to find the a square. So a square, how will find a square? A square means what? A into a, same matrix. You have to multiply twice. So when you find a square, it will be what? 2 minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2. Okay. So let me check once. This 2 minus 1, 1, minus 1, 2, minus 1, and then 1, minus 1, 2. Okay. The same matrix, you have to multiply twice. 2 minus 1, 1, minus 1, 2, minus 1, 1, minus 1, and then 2. Okay. So you multiply this one, so because you know multiplication, otherwise the video will get a little bit more long. So let it be equation number 1. So therefore equation 1 implies A inverse equals to 1 by 4. So what we'll do first, we'll put the matrix A. Okay. First we'll put this one, the value of a square. So a square will be 3 by 3 matrix. Then 6 into our A is 2 minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2, and then 9i. Our I is 1, 0, 0, 0, 1, 0, and then 0, 0, 1. Okay. So we can calculate each and everything. So after calculation, this will be the final answer. So just kindly calculate this part and you will get this answer. 3, 1, minus 1, 1, 3, 1, minus 1, 1, and 3. Okay. So if you are getting a different answer, then kindly write in the comment box. I'll check once again. So I hope you understand what is Cayley Hamilton theorem.